In this lesson, we're going to look at a couple other types of equations that you may encounter in your algebra course. So far, we've covered linear, rational, and quadratic equations. But next, let's talk about polynomial equations. And let's start off by reminding ourselves what exactly is a polynomial. A polynomial is just some mathematical expression consisting of constants and variables. And our variables can only have non-negative integer exponents. So think, 0, 1, 2, 3, etc. So let's take a look at just a few basic examples of some polynomials. So if we have 4x plus 3 equals 19, maybe we have a quadratic 3x squared and to the third. So these are just a few examples of some basic polynomials. All right, again, it's just constants and variables, and our variables can only have our non-negative integer exponents. So here we have 1, 2, 3, so on and so forth. So no negatives, no fractions. So what we could not have, these would not. For instance, these would not be polynomials. Say we had over x. We have a variable in the denominator, that would not be a polynomial. And if you were to move this up to the top, think of this like x to the first, and then if we get rid of the fraction, if we move it to the top, then that would become, just switch the signs, then it becomes 2x to the negative 1. And again, we can't have negatives in our exponents. So that would not be 1 if we had the square root of x. We can't have a radical containing variable. And if we had 4 to the x, we can't have a variable in the exponent. And then again, like I said, no negative exponents, no fractional exponents. So all of these here would not be polynomials. So now that we know what exactly a polynomial equation is just the result of setting two polynomials equal to each other. So say we had 2x squared plus 4 equals x plus 10. So we have two polynomials, one on the left and right side, and we just have them set equal to each other. So this is just a basic polynomial equation now. And our polynomial equation, the general form that is useful for when we're trying to solve, is when we have the equation equal to 0, and then the side with the variables is in descending powers. So for instance, if we had 3x cubed plus x squared plus 2x plus 7 equals 0, right? This would be a proper general form for us. We have it set equal to 0, and then we're in descending order. We have to the third power, to the second power, this would just be to the first power, and then this would be, well, the one at the end just has no x variable at all, so that one would go at the very end. And then from here we could work on trying to solve it. So if we can, it's nice to have it in this general form, if we can, before we go about solving it. Let's take a look at an example. So if we had 9x cubed plus 9x squared equal to x plus 1. All right, so let's work on getting everything onto one side and getting it set equal to 0. And I think it would just be easiest if we move what's on the right over to the left, because we already have these in third to the second. So let's just move these over, because these are ordered. These moved over. Right? Let's do it. So we'll subtract the x over, and then subtract the 1, or minus, and then subtract the 1 over as well. So now we'll have 9x cubed plus 9x squared, and then minus x and minus 1, and now we just have 0 on the right side. So we got it equal to 0. We're in descending powers in our exponents. So let's work on solving it from here. Let's see if we can factor this. We're going to do factor by grouping. If you recall, that's the one where we're just splitting it right down the middle, and then we're going to work on factoring this side and then factoring this side. So let's start with over here on the piece on the left side. So what can we factor out? We have 9x cubed plus 9x squared. What's the biggest piece we could factor out of there? So, and then we know we can do an x. They both have an x attached to them. And looks like the highest power we could do to the second, because that would clear that, take 2 that exponent. So I think 9x squared is going to be the biggest piece we can take out. So what would be left on the inside? 9x squared times what gets us 9x cubed? That would just be times x. And then 9x squared times what gets us 9x squared? That's just 1. Okay. Still have a minus here. And then what about here? What's the biggest piece we can take out? Looks like it's just going to be, obviously we can't attach an x because 1 doesn't have an x. So it looks like the biggest piece is just going to be 1. So if we take 1 times what gets us x, well, that's just x. And then 1 times what gets us negative 1. Well, technically, if we were to factor this, it'd be negative 1 times what gets us to negative 1. That would be times positive 1. Because if we were to distribute this and put it back into this form, we'd end up with negative 1 times x is negative x, and then negative 1 times 1 is negative 1. Okay, so we still have that equal to 0. And then we now have our two parts, just what we wanted to happen inside the parentheses. They are the same, x plus 1, that is perfect. So that'll be one of our parts we can set equal to 0, and then the other is the part that's left over on the outside of the parentheses. So we'll have 9x squared minus 1 equal to 0, and then we'll have the part inside the parentheses, x plus 1, equal to 0. So we applied our zero product principle, and now we can go about solving from here. So we have 9x squared equals 1, and then we can divide by 9, get the x squared by itself. So x squared is equal to 1/9, and then apply the square root property. So that's going to be x, and then this will be plus minus, remember, square root property, plus minus the square root of 1 over 9. And that can be simplified for us, because if we were to take the square root of 1 over 9, that is just equal to it's the same thing as taking the square root of 1 over the square root of 9. So we can simplify the square root of 1/9. So square root of 1 is just 1, and then the square root of 9, square root of 9 is 3. So the square root of 1/9 can be simplified to just 1/3. And we still have, of course, our plus minus. All right. So that's our solution for that part. And then we still have this one here, minus 1. So x is equal to -1. All right, so those are our solutions. For that one, we have 3 solutions, -1, and then positive 1/3 and negative 1/3. So that's solving a polynomial equation. We solved it by factoring by grouping. And let's take a look next at equations involving radicals. A radical equation just being an equation in which the variable occurs in a square root, or maybe in a cube root, or any higher root, right? Anything like that, and so on and so forth. So radical equation just involves a variable which occurs in a square root. So let's take a look at, well, actually before we solve one, it may be helpful to review when we're talking about our radicals. Now the number on the part on the inside, we'll just say it's to the a power. The part on the inside, that's our radicand. And then this will be our key part for us. This is what we call the index. All right, the part kind of right in the notch of the square root symbol. That's our index. And now if we just have a basic, kind of like we're used to seeing for the most part, if we just have a basic square root symbol and there's nothing in the index, then it's an implied 2. All right. So if you don't see anything in the index, then it's just an implied 2. So we'll remember that going forward. And if we wanted to get rid of a radical, like let's say you had, just the square root of x plus 2. All right. And we wanted to get rid of a radical, all we would have to do is take, well, we'll just say that's equal to x plus 2. All we would have to do is take it times whatever is in the index. Again, this would be, there was nothing there, so that's an implied 2. So all we have to do to get rid of the radical is take it times whatever is in the index. And of course, we have to do it to both sides. Okay, because then the radical and by squaring it, they cancel each other out. So then we'd just be left with x plus 2 equals x plus 2 squared. Okay? And that works if you need to show you exactly why it works, because if we're taking x square root of x plus 2, and we're taking that and squaring it, let's just look at a basic square root of x. So again, that's an implied 2, and that is equal to, that's the same thing as saying x to the 1/2 power. Right? Again, this is our index, an implied 2, and then this would just be a 1. All right, that would just be a 1 on the inside in the radicand. All right, and the index is always the number in the denominator, right? All right, the number in the index correlates to the number in the denominator. So why that works, if that's equal to, if the square root of x is just equal to, same thing as saying x to the 1/2, well, if we're taking x to the 1/2 and we're squaring it, we're taking it, be the same as 2 over 1, we're taking it times its reciprocal, and they cancel each other out. So that's why, in this case, these would cancel out, no different than if you had the cube root of x, say it was equal to 10, all right, so we take it times to the 3rd power, and we do it to both sides, and then these would cancel out, and we would just be left with x. Because again, this would be the same as saying x to the 1/3. Again, the index is the number in the denominator, and we can get rid of that by taking it times its reciprocal. So let's keep that in mind going forward for getting rid of radicals when we're trying to solve. And let's take a look at an example. So let's say we had let's say we had 2x equals 1 minus 2 minus x. All right, so we have a radical equation, right? Variable occurs under the square root here, right? So first thing we're going to want to do to start solving this is let's get the radical isolated. Right, let's get it, we'll leave it on the right side, but let's get it by itself. So let's subtract this 1 over. So we have 2x minus 1 equals, we still have the minus here. All right, and now from here, now that we've got the radical isolated, our next step is going to be to raise both sides to the number in the index. All right, so again, this would be, there's nothing there, so that's an implied 2. So we're going to square it, and then we have to do it to both sides. All right, so when we do that, so we end up with 2x minus 1 times 2x minus 1 equals, and then in this case we'll get the square root and the negative out in front to cancel out, because the negative times the negative would just get us a positive. So we just have 2 minus x left over on the right after that cancellation. And now let's work on getting everything moved over, and let's get it set equal to 0 and see if maybe we can factor this. So well, first off, let's FOIL this. Let's get this expanded. So we have 2x times 2x would get us to 4. It's 4x squared. And we'd have 2x times -1 minus 2x, -1 times 2x minus 2x, and then -1 times -1, 1. So we can combine -2 minus 2, so we'll be at minus 4x plus 1. And then let's get these moved over so we can add the x and then subtract the 2. So we have 4x squared, -4 plus 1. So now we'd be at -3x, and then 1 minus 2 would put us at -1. And now we just have 0 left over on the right side. So now we can work on factoring this. Okay, and remember, for factoring, we have to take a times c. So in this case, we have this is our a, this is our b, and this is our c. So 4 times -1. So we have -4. So we need it to multiply the -4 and then add to b, which is -3. So let's try. I mean, we're either going to have 1 and 4 or 2 and 2. I think we should try -4 and 1. Okay, if we do that, because that would get us -4 times 1 is -4, and then -4 plus 1 would get us -3. So -4 and 1 are going to work out for us. So now we're going to split the middle term using these numbers. Again, we have, if you remember back, we have this extra step here because our leading coefficient isn't simply just a 1. So we can't just go right into, when we put our parentheses, went right into it, put parentheses with an x and an x, because our leading coefficient is not at 1. We had that extra step here we need to make sure we do. So we're going to split the middle term using these numbers that we came up with. So now we'll have 4x squared, and then we'll have minus 4x plus 1. This gets just plus x plus 1 equals 0. And then just like we had just done a minute ago, we're going to factor by grouping again. So split here, halves. So what's the biggest piece we can pull out on this side? Each have an x, so 4x, and then 4x times what gets us x squared, that would just be x, and then 4x times what gets us -4x, would just be -1. And then same thing here. What's the biggest piece we can pull out? Looks like it's just going to be a 1. 1 times what gets us x, just be x, and then 1 times what gets us -1, -1. So perfect, because our parentheses is the same as the part on the outside. So we can do our zero product principle. So we have 4x plus 1 equal to 0, and then x minus 1 equal to 0. And then if we solve those out, we just simply get, subtract the 1, divide by 4. So we have x equal to negative 1/4, and then x equal to 1. But here we have to be careful, because these are only potential solutions. When solving radical equations, the last step we need to do is checking our potential solutions in the original equations, or equation, I should say. So here we have, again, these are potential solutions. We have negative 1/4, and we have 1. So let's verify here. And our original equation, again, was, we had 2x equals 1 minus 2 minus x. All right, so we'll try the negative 1/4 first. So if we plug that in for each x, okay. So we have 2 times negative 1/4, that would just be negative 1/2. All right, if we multiply across, 2 times negative 1, and then 1 times 4, so that would just simplify to negative 1/2. And then over here we have 2 minus negative 1/4 be 2 plus 1/4, so we'd have 2 and 1/4, and that I'm going to just make into, and you'll see why this works out nice to do it like this. Let's just change that into a single fraction. So we take 4 times 2 plus 1, so that's 9, and then carry over the 4, that goes in the bottom. So 2 and 1/4 is the same thing as 9/4. So let's replace that. And then remember what we said, the square root of 9/4, that would be the same as the square root of 9 over the square root of 4. So square root of 9 is 3, and then square root of 4 is 2. So that can be simplified to 3/2. So now we have negative 1/2 equals 1 minus 3/2, and 1 minus 3/2 would get us to, so that's equal, that is also negative 1/2. So that indeed does work when we plug it back in. So negative 1/4, so negative 1/4 is absolutely a solution in this case. And then if we were to plug in 1, okay, so we'd have, right here, 2x equals 1 minus, all right, so we'll check our other solution here. So 2 times 1 is 2, and then 2 minus 1, just 1. So we have 1 minus square root of 1 is just 1. So it looks like we end up with 2 equal to 0, and that does not work. So 1 in this case is not a solution. So that's why it's important for when we're dealing with the radical equations, it's important for us to check our solutions. So at the end here, our only solution for this one is negative 1/4. Let's try another one here. How about if we had Square root of 22x minus 33 equals x plus 4. Now in this case, radical is already isolated. So let's move on to our next step, which would be getting rid of the radical. So take it times the number in the index, which again, in this case, would be an implied 2. Do it to both sides. So the radical is gone. That cancels out. So we're just left with 22x minus 33. And then we have x plus 4 squared. And let's get this expanded. So we have x times x, and then we have outer and the inner. We'd end up with 4x plus 4x, so 8x. And then on the last terms, 4 times 4 is 16. And just like we did before, now let's get everything moved over. Let's get it set equal to 0. So if we add the 33, we have x squared plus 8x, and 16 plus 33 will give us 49. And then subtract the 22x from the 8x. So we end up with 0 on the left side equals x squared, and then 8 minus 22 would come out to a negative 14 plus 49. Okay. And now let's go about seeing if we can factor this. So we can go right into this because our leading coefficient is just 1. So we're looking for two numbers that multiply to 49 and add to negative 14. Well, I'm thinking it's going to be a 7. 7 times 7 is 49. But because we have to hit a negative 14, they have to add a negative 14, we're going to have to do negative 7 for each one, because the negative times the negative will get us the positive 49. So we'd have x squared, and then negative 7x minus 7x would get us to the negative 14x, and then negative 7 times negative 7 would get us to positive 49. So this does indeed work. So in this case, for our zero product principle, we only have one equation to worry about. So x minus 7 equal to 0. So it looks like x is equal to 7 in this case. And again, like we said before, this is a potential solution. So let's check it in the original equation. So we'll have the square root of 22 times 7 minus 33 equals, and then it was x plus 4, so we'll have 7 plus 4. So we have 22 times 7, that'll get us to 154 minus 33 equals 11. 154 minus 33 is 121. And the square root of 121 is indeed 11. 11 equals 11, so that most definitely works. So x equals 7 is our lone solution for this radical equation. All right, let's shift gears. Now, if we were given a higher degree polynomial, let's say maybe we were given a a fourth degree polynomial. Maybe something like this. All right, our highest degree is of 4, so we have a fourth degree polynomial here. And we were asked to figure out the solutions. And solutions like this that are not in quadratic form, where it's a second degree equation, solutions or equations that are not in quadratic form can be written as quadratic equations using appropriate substitution. So here's where we'll be looking at some substitution in order to solve. Because quadratics we can work with, we've dealt with those before, so if we can take something that's in a higher power, like this x to the fourth, and we can put them into quadratics, that would be something that would be much easier for us to work with. And by expressing an equation like this, by expressing it as a quadratic using substitution, then we would just say that it's quadratic in form. All right, we're changing it from a higher power polynomial, and we're using substitution to put it into quadratic form. We would just say it's merely quadratic in form. But let's see an example of this. So we're given some higher power polynomial, x to the fourth minus 29x squared plus 100 equals 0. All right, so we got a fourth degree polynomial. So let's see if we can use some substitution to simplify this, perhaps get this down to a quadratic, something that we know we can work with. All right, and I like to use, for my substitution, I just like to use u, call it u substitution. All right, so that's what we're going to use here. We're going to use substitution to solve. So we're going to make our u, we're going to make this our u. We're going to say u is going to be equal to x squared. Okay. So that'll be able to sub in right here. And then for this fourth degree variable up front, if we were to say u squared, so if u is equal to x squared, then x squared squared would be equal to x to the fourth. Because when we have, in this case, we just multiply the 2 times the 2. Right? When we have an exponent in the parentheses and on the outside, when we're simplifying it, we just multiply out. So this is equal to x to the fourth, which fits in perfectly right here. So we said u is going to be equal to x squared, and then u squared will be equal to x to the fourth. So now once we have that decided on, now we're able to plug in. All right, so let's switch it out with our u. So this is going to be u squared, and then this will be minus 29, and then we said x squared was equal to just u plus 100 equals 0. So now we have it in something. We went from a fourth degree polynomial to a quadratic, something that we much better know how to work with. So let's see if we can factor this now. So we need two numbers that multiply to 100 and add to negative 29. So it looks like we're going to have two negatives in order to get to the negative 29, and then two negatives will get us the positive 100. So we're going to have to do 25 and 4. All right. So we have negative 25 times negative 4 will get us a positive 100, and then negative 25 plus negative 4, so minus 4, would get us to our negative 29. So now we can apply our zero product principle. U minus 4 equals 0, and U minus 25 equals 0. So U is going to be equal to 4, and U will be equal to 25. But we can't stop here. When we're doing U substitution, be mindful not to stop when you get to this point, and because we've only solved for U, we need to put things back in terms of x. So obviously our original equation was in terms of x, so we were just using U substitution to make it easier to solve, but we have to put things back in terms of x. So again, we said that U was equal to x squared. So in this case, we'll have, if U, now we're saying U is equal to 4, so we're saying 4 is equal to x squared. Then same thing here. We said U was equal to 25. Well, if we plug that back in here, so now we're saying 25 is equal to x squared. All right? So we need to plug back in and put things back in terms of x. And now we're just doing some square root property here on each of these. So we'd have x equal to plus minus 2, and then x equal to plus or minus 5. So in this case, we have 4 solutions, because now we are finished. We have things back in terms of x. All right. So that one has 4 solutions. We have negative 2, positive 2, negative 5, and positive 5 for that one, which we should realistically have gotten because our original equation was to the 4th power. So just kind of a little cheat. We should have, being to the 4th power, we should have gotten 4 solutions. Let's take a look at one more substitution one. Because another case where using substitution would be an effective method, not just for higher powers like we did in the last one, but even if we were given fractional powers. If we were given something like this, x to the 2/3 minus 2x to the 1/3 minus 3, so we can use our substitution, we can use our u sub again to make this something manageable for us. All right, so let's make our u. All right, we'll make our u again. We'll go right here to the middle. U is going to be equal to x to the 1/3. All right, so we have this one covered. So right now we're at minus 2 times u. And then we're going to make u squared. That would be x to the 2/3. So this would just become u squared. Because again, if we take x to the 1/3 and we square it, and we just multiply, so we're just multiplying fractions now. 2 times 1 is 2, and then 3 times 1 is 3. So that is x to the 2/3, and that works out just perfect for us. Now we put our u in, so we have u squared minus 2u minus 3 equals 0, and this is far more manageable than our original equation. two-factor. So let's get two numbers that multiply to -3 and add to -2. If we had -3 and 1, that would get us, let's see, we'd have u squared minus 3u plus u minus 3. -3 plus 1 is -2, so this works out perfect. All right. So let's apply our zero product principle. So we have u plus 1 equal to 0, and we have u minus 3 equal to 0. So u is equal to -1, and u is equal to 3. And again, just like we did with the last one, we cannot stop here. We have to put things back in terms of x. So we said u was equal to x to the 1/3. All right. And now we're saying u is equal to -1. So let's plug the -1 in. So we're saying -1 is equal to x to the 1/3. And then we can say u equal to 3. So now over here we have 3. We have 3 equals x to the 1/3. Okay. And how can we get rid of this 1/3? If we just take it times its reciprocal, 1/3 times 3, take it times its reciprocal, those will cancel, but just don't forget you have to do it to both sides, of course. So we just have x left over, and then -1 to the 3rd power would get us, we'd still be at -1. Since we have an odd exponent, it'll remain a negative. So that's still just -1. And then if we do the same thing over here, take it times its reciprocal, do it to both sides. So that cancels, and we have x equals 3 cubed. So 3 times 3 is 9, times 3 is 27. So we have x equal to -1 and x equal to 27 as our solutions for that one. All right, so that does it for this lesson. Hope it was helpful, and thank you for watching. And be sure to check out the channel for more algebra lessons.